Alright, it's another draft physics video presentation. It's almost a production, but sorry, not yet. Anyway, so I guess it's pick on the dissident day, because the dissidents often need the picking on. Is they're just proposing something just as unproven and undemonstratable and illogical and nonsensical as the conventional mush. And they're not fixing anything, they're just taking something that's a mess and making some sort of new mess and saying, there, it's a new mess. Don't you like the new mess better? No, don't like it better. So anyway, there's lots of these ether type people, this ambiguous ether theories. And Fractal Woman has some sort of ambiguous ether type theory, no explanation for how this ether thing works. Sorry about the squeaks. There's not much I can do about it. I have to live with it. Louder than usual. But anyway, where was I? Squeak. All right, anyway, try not to pay attention. Okay, I'll try to too. Anyway, so Fractal Woman's, one of these ether people. The ether people never explain to you what this ether is, why it's undetectable, blah, 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 blah. No real explanations. I'd argue this, the arguments are always the same arguments I'm going to be making, in the sense that the logic kind of tells you the universe is being pushed together. So Fractal Woman's associating herself now with Jeff Yee, who has, has a very pretty theory, but it's not very functional, or, doesn't, not very grokkable, in my opinion, and it's full of a few just mathematical gimmicks. They're gimmicks. They're really not saying anything that we don't already know. But anyway, so in his theory is essentially the idea that the energy is coming from cells, so to speak, like the little bits of the universe. If you were to think of the universe having some sort of bit, that there'd be a center to, say, things like atoms, and at the center is some sort of thing, the magic force, that the jellyfish, I call it, jellyfish theory. That the center of each atom has a little jellyfish in it, and little jellyfish is creating the initial energy, and that anything that happens because of that initial energy somehow comes back and holds everything together. And I could say to you, logically, you could sort of understand that if the energy was coming from the inside out, that the tendency would be to blow everything apart, not to compress everything. So the universe would be falling apart right in front of our eyes all the time, because there'd be more pressure on the inside than there is on the outside. And that's sort of how I have to think about it, is there really can't be more real pressure, more real movement on the inside than there is the outside, or everything would just fly apart. So the pressure has to come from the outside. It's a push universe. And these videos should be able to get into some of that, but it gets into Maxwell's equations and the whole idea of what is this electromagnetic stuff that they keep trying to smash together into something called an electromagnetic wave or whatever. And yes, all of the conventional theory is mush, and they don't want to replace the conventional theory with something unmushy. They just want to force them to call their electric field and their magnetic field ether, instead of calling it electric field and magnetic field. They want to call it something else, but they don't want to make it out of something else, or make it do something else, or make it more real, or make it more of a thing. They just want to change its name, essentially. You can put Ken Wheeler in the same category. Again, keeps griping about Einstein, and Einstein basically conceded. Why doesn't he just show that quote of Einstein's, where Einstein's basically conceding that for space to be bent, it's got to be made out of something you're bending. It's got to be a something, not a nothing. So there's no empty space. He's basically conceding the point to the etherists. So why don't they just make him their icon? But anyway, because this is just a word game, it's about some sort of the agenda of these people isn't honest, in the sense that they're not really after the truth. They're after a way of demonstrating that God done it, or the magical forces did it, the fairies did it, the good intenders did it. So that it has some sort of, the system is just way too complicated down there, and the small universe is way too complicated. It must have been invented by something with a brain, because it's way too sophisticated. La 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 la. It's all just nonsense. There's one universe, it's the small universe, and that's the only one there is. So that's sort of the way I thought to describe all of this. Now, there are people who do make sense now and then, like the Franklin Who guy now and then says something like, well, I can see the longitudinal part of the wave, but I can't see this, this wave going more than one direction at a time, multi-tunical. Bisected wave doesn't make much sense, and it's just like a sound wave, and so they start to get close to it. But I would argue that the sound wave is sort of a giveaway, and how the system basically works is that it's just about energy reflecting. And so when you're going to make a sound, what are you doing? You're taking big clumps, atoms, and you're moving them into big clumps of atoms, right? So there's little atoms out here, the atmosphere atoms, and all you're really doing is saying, look, I can make sound travel. That is, I can make movement here, create movement over here. Okay, so you just have another same system over here, a bunch of little atoms. And what I can do is I can push, these atoms can push out, and that'll cause these atoms to all move, and that'll cause these to push in here, and I can take this signal and I can make this thing hear it. Okay, and that's basically what sound does. So sound is dependent on a medium of atoms that are loosely but real connected. Okay, they might have a little distance between them, but their electrons are communicating with each other. There's tension and pressure between them. They don't like each other, generally speaking. Don't like each other too much, and therefore, when you change the position of these atoms, you're going to change the position of these atoms, and therefore change the position of these atoms and get an effect. And the key is that the effect travels at a certain speed, because that's the speed of the tension between the atoms, how quickly they bounce into each other. So they're like loaded with little springs. You could think of it just as springs between the bits. And it takes a little time to compress the string. So this one pushes in, takes a little time for this one to figure out, hey, the spring has been compressed, I gotta move. So it takes a little time for it to do that, and that's why it takes time to move through the medium. And it's pretty straightforward, not too difficult to understand. And really the same thing is happening with the electromagnetic spectrum, except you're working with the smaller bits. So instead of it being atoms, okay, that you're fiddling with, what you're really fiddling with is the movement of, they say, the movement of charges. See, that's what they call electricity, is the movement of charges. But really it's the movement of electrons. Okay, so call them what they are. And they move. And when they're moving this way, when you're pushing them this way, you're also pushing them this way, all right, because you're building up pressure between them. And when they're in a conductor, they're saying, I don't like being pushed into this guy. And so, I'm certainly not going to go this way, because there's more electrons in here. Okay, there's a whole bunch of them in here. There's some over here where I'm pushing, and there's less out here. So that's the way they tend to want to go, is that away, out towards the surface. And so they create a new surface out here in the real world. And so now we're just going to say, now how does that travel? Okay, the electromagnetic stuff travels through a vacuum. So now there's no more atoms in here to help it. And so the question is, how does that movement of that electron get transmitted to this other surface to cause the same effect, which is to push the electrons in? Push them in, push them in, push them in, push them in. And the key thing to it is to understand that there's pressure in this system. That is, there's always stuff moving through the universe, hitting surfaces, constantly hitting all the surfaces. And the truth of the matter is that if I move this surface out, I'm going to get the same effect, and then I'm going to cause a reflection that's going to happen in a closer location. It's further out, right? I move the surface out. It was here. I move the surface here. It means the pressure is going to reflect here instead of here. Here is going to take more time. This is more time here, right? see that, right? Yeah, I got plenty of room up there. Plenty of room. All right. And so this is going to take less time, and that means more pressure. So the sooner an impact gets to something, that's essentially more pressure. So the more impacts, the more interactions, the more pressure. And the closer I bring the surfaces, the more they're going to reflect back and forth, the more energy you're going to have caught in a system. It's that simple. But what's really happening is there's a bunch of pressure in the universe, and it's hitting from all directions all the time. And it's essentially showing you what every surface looks like. It's like radar. There's energy coming at us from all directions, and we're reflecting it. It's just a fact. And if you have the right instrumentality, you can detect it. Now, the flaw in the perfect system is it'd be great if we could detect this stuff when it's just one bit. But we can only detect it when it has a real standard frequency, and this frequency has to have a specific number of nodes. 6 to 9 nodes, or we can't receive it. And this is true for radio waves too. We can't receive them unless you get enough frequency for the oscillator to oscillate at the same frequency and start pulling information off. And so we're very dependent on there being a consistent ray length for us to see anything. And so we can only see the radar, so to speak, the energy that has a frequency. So visible light has a frequency we can detect. There's lots of invisible light we can't detect. We know it's there. We know that's in big enough chunks. All of the rules are being met. It's just that the device won't detect it because it's the wrong frequency. So there's not only limits on what we can see and why we see it, but there's reasons why there's other stuff out there that we don't see that's not even broken or in any way, it's there. There's no real good reason we don't see microwave energy. The only good reason is because as a biological organism it didn't have any utility. But we can make detectors and we can tell where there's more microwaves coming from that direction or that direction. But we always have to tune it to a frequency, a specific frequency. So we can't see, a huge range of frequencies all at once without making a very sophisticated device. And even then, it has its limitations. But the point is that all you're talking about is movement. When there's movement of the hard bits, okay, the matter bits, the force bits, the little energy bits, bounce off of it and give us information about it. Okay, because they're going to change. If this thing moves towards you, it's going to change the pressure you're going to feel from it in terms of it's going to be making stronger and more reliable reflections towards you, and its presence is going to become more and more obvious to you. And so an ether doesn't work if your ether isn't already charged, so to speak. So if you have some vision of the universe being some jello molecules all smashed into each other, and there's no real force bits, there's no real things moving, and you're just saying this is, you move one of these things and then they all transfer the movement. The problem with that is it creates no innate pressure. They all have to be already moving. You can't have any static ones because they would absorb the energy. Then you'd have a signal that's heading through, and if you had a dead bit that you had to move, you use up the energy moving the dead bit. It wouldn't be a lossless system. The only way you can make it a lossless system is every one of these little bits has to already be heading somewhere. And it'll do the exact same thing as your ether, in the sense that it'll appear, okay, as a system in tension, or things will travel right through it, because the little bits don't interact with each other, because of the rules of head-on collisions are pretty much, that you're not going to be able to tell a perfect reflection from a perfect miss. Energy in, energy is going to be the same as the energy out. Two things hit each other, one's going to go that way, one's going to go that way, whether they miss, whether they reflect, or whether they go right through each other. The universe looks exactly the same. And that lossless system works for communicating the energy. So all you have to do is have bits moving the speed of light, fill the universe full of BBs, then put some harder bits, bigger, harder things in that field, And the bigger, harder things, the BB goes inside and stays in there for a little while, gives it the momentum it went in with, moves it about, okay, and then it gets hit by some other BB, and that essentially ends up being another exchange in the opposite direction and stops moving in the direction it was and moves, stops moving. And that's all the universe is. So it just positions. Everything's just a position in space, and it's just about movement. The energy's moving, it causes the bits to move, and if you create imbalances in those BBs by blocking them and deflecting them and doing different things to them, then you can create locations that have high pressure and low pressure all throughout the universe and cause attraction and repulsion. Yeah. So, close enough. Yeah, it's close enough. I'll erase on a break, I suppose, if I need to go any further. All right, goodbye. I'm going to need to go further pretty soon. So let's play a little bit of this just to get the idea of their counter theory.
So I'm on a bit of a roll here with making videos, so I thought I would at least start with this next video that I wanted to make on Maxwell's equations. Now, I just recently read this paper called Trouble with Maxwell's Electromagnetic Theory.
All right, so they're overtly making a challenge to Maxwell's theory. There's no theory. There's just the equations. And Maxwell didn't have a modern theory because he didn't know what electrons and protons were. He didn't know enough nuclear physics to have a theory. He just had an explanation for the relationships that exist between a concise way of understanding how the phenomenon of electricity is related to the phenomenon of magnetism. But he didn't really have a theory. He was an etherist. He had lots of beliefs, but they didn't really have anything to do with his equations in any overt or necessary way. And the foundation of the equations are an understanding of what charge is. And I've been over this before, but that's really the beginning of it, is understanding that there's electrons and protons, and they have fundamentally different behaviors under the same conditions. So you create a condition, and you put an electron in, it'll behave fundamentally different than how, exactly the opposite, sort of, than the proton will in the exact same condition. So, and there's this inverse relationship, where they both do the same different thing in the opposite environment. So if in one environment they shoot away, in the other environment they come towards. Attraction and repulsion is essentially the overt action. I would argue the reason for the attraction and repulsion is because there's two forces, okay, just like there are two charges, the electron and proton. There's two forces that go with those two charges, and therefore explains the inverse relationship. Now, I've already done that part enough times that I don't think I'll do that again. But what I will do is take a break. All right, maybe I'll explain this part first. Okay, so she's going to talk about a paper. It's a 2012 paper. I thought it was more recent than that, but anyway, from what she described. And so it's by the Lionel Dinu, spelled in capital letters, which is kind of weird, D-I-N-U. Anyway, physics teacher. Anyway, so his claim to fame is, again, I don't know whether he has any proprietary rights to this observation. I'm sure it's something that's been observed many times. And it's, it's really has to do more with, what do you call it? Liquid dynamics. It's a word for that whole subject. But anyway, the idea is you take something in water, a medium, gluey medium, sticky medium, and you spin two objects, in different directions. And I guess I should just do that this way, and then you'll see they're two different directions or the same direction. And you can sort of just figure out for yourself what's going to happen is that as you spin the object, there's friction, okay? That means there's adhesion with the water molecules, and the water molecules will all start to spin, okay, around the stuff. And if they're spinning in these opposite directions, you can sort of understand how that's going to create pressure. They're going to end up, the water is going to end up creating turbulence because this water is going to hit this water going the opposite direction, and there's going to be a conflict, and the two objects are going to tend to drift away. Now, it's incredibly weak force, so you have to put a lot of energy in to get a tiny effector out. So nothing like magnetism, like 1,000,000 times weaker, literally, in terms of, for magnets, we don't appear to see any energy going in. Okay, none, zero. No energy consumed at all to produce very strong attraction and repulsion. So the opposite effect would be if they're spinning in opposite directions, means they're going the same way on the same side, and then they would be going into each other. Or maybe that's the one that repels. And you can sort of get it that they would, this water would be moving this way, this water's moving this way. They both have components in opposite directions, which means there's going to be a conflict, and they're going to end up pushing away from each other. And that they would roll to where there's less pressure. So here, all the pressure is going out, right? And so what they're going to tend to do is they're going to roll into that less pressure, the low pressure, and so this one's going to tend to just roll its head to face this one's, so they can match their to just because of the amount of pressure is being created. So they're being pushed apart up here, and they're tending to be pushing towards down here, and so that's going to end up making them tilt and move. Now, a tiny effect, a ton of energy, just nothing, it just isn't even close. It can't be called like, oh yeah, this is the indication of the real cause of magnetism and why and they all use this. Bill Gates, Ken Wheeler, Fractal Woman, they're all using this, the Hillsters are using this terribly feeble mechanism for creating a tiny bit of movement away or toward, and saying that's the origins of magnetism. And I would argue it's nonsense. The movement isn't just like a magnet. It's quite different than a magnet in terms of where you're creating, how you're creating the repulsion and the attraction. And it's just, it has a slightest of similarities, barely similar. All right. What do I want to add to that? Okay, yeah, so I guess I can show you the other part. So really, there's just no way to make this effect into an explanation for magnetism, because the amount of energy you'd have to create is tremendous, and there'd be absolutely no reason that if this force, this swirling water, could actually move these objects, these solid objects, that we couldn't detect that swirl by just sticking an electron in and see if it'll swirl. And it won't swirl. It'll do what Maxwell says it'll do, largely. But even Maxwell's equations don't cover electrons next to infinite planes. The rules change when the proportion of the object is much bigger than the object you're testing for. The rules change. You can't use Maxwell's equations with two light sources, okay, that are very close together. And then if you had sensors right in the middle to detect how much light, there would be no inverse square law. There'd be none of that anymore. It would be the same intensity at any one of these, at any separation. You'd end up with the same intensity because you've created essentially an infinite plane. And so the equations aren't applicable. That's the qualifier for all of these. These are general equations. They're not for every case. And they break down under certain conditions that happen in the real world. So they're not perfect, and they're not universal and all of that mush. And that should be the simple argument they make. All right, so the other example, the other Bob D. Hilster did an argument about the magnetic field or charge, and they're claiming a charge doesn't exist, and because they're going to make the swirly stuff doing it. They're going to say swirly stuff is somehow creating the phenomenon of movement of electrons and protons, and it just can't work. It can't create the what we know from experiments what how the movement is, and the only way to explain it is from point charges radiating energy, which I have gone through before, but I'll do that again. And so he has this case where he's saying that somehow trying to imply that the magnetic field of a battery is demonstrating that it's the same as magnetism, when what it's demonstrating is that there's electrons at one end of the battery and there's protons, more likely to be protons exposed at the bottom, and that means there's less electron pressure at the base of the battery and more electron pressure at the tip of the battery. And of course, okay, just like the North Pole of a compass will repel electrons, and just as a magnet will repel the North Pole of a magnet will repel an electron, the same thing is going to happen here. They're obviously going to be just as attracted because north and south are the same thing as positive and negative. It's the same thing. The north is the electron side of the magnet. The south is the proton side of the magnet. If you want to repel an electron, you use the north end of the magnet. If you want to repel a proton, you use the south side of the magnet. The two are connected. So all you're demonstrating is that electrons are fundamental to the function of magnetism, which they already should know that electrons and protons are in fact the the magnetic monopoles. So anyway, so it's a very weak effect, though. A battery is insanely weak as a magnet compared to a magnet. And so he demonstrates this by doing this thing where he puts a magnet in a battery under the identical circumstances, but there are obviously circumstances that are very deceptive, because in the case of the magnet, these needles are strongly attached, strongly pointing. You move them a little bit away and they'll stay exactly where they're pointing. But if you move them just a tiny bit away in the battery case, no, it's all gone. You won't feel, there won't be any magnetic field, because it's not really the magnetic field that's pulling them there. They're being pulled because electrons are attracted to south end, and the south end is attracted to the electrons, and there's low pressure between them, and there's high pressure on the other side, inversely to the other side of the needle. And so it's just demonstrating that electrons repel the north side of the needle and attract the south side of the needle, and that's all it's demonstrating. But it's like I said, it's not really magnetism. It's just another charge phenomenon. You're just demonstrating that electrons don't like electrons. The point is the north side of the magnet is behaving just like it was an electron, and the south side of the magnet is behaving just like it was a big proton. That's how it's behaving. If you could make them if you could make giant electrons and stick them on giant protons, they'd make magnets, powerful magnets. It's the same force. Now the only difference is charge is a surface phenomenon, and magnetism goes through the entire material, becomes magnetized, and that's one fundamental difference. And also obviously in the static charges, you can increase the charge by increasing the voltage, and so magnets can't do that. So I think that's all I need to say about that. So you can really increase the density of charge for charges by just increasing the number of the electrons exposed, the amount they're exposed. The more exposed, you can vary it, where magnets only have so much exposure because you're making the magnet out of an atom, and you can't make the atom, you can't stretch the atom really far. You can't, there's limitations to what you can do to the atom in terms of increasing its voltage. All right, so back to this video. This one, I guess I'll play a little more of this just so you get the idea.
Can fields induce other fields in a vacuum? And this was written by a guy named Yonel Denyu. Now you'll recognize him as the guy that made the video that I showed you of the spinning cylinders in water. And he showed that when you spin two cylinders in water, whether you spin them axially or side by side, they behave very much like magnets.
So they're making these assertions that they behave very much. It's barely, they move a little bit. All right, but it's really clunky. Nothing like real magnets that move really, really fast and very, very assertively. No doubt about where they're going and why they're going there. Where the mushy fluid pressure dynamics, fluid dynamics, I guess is what they call it. There's really no fair comparison between the two. And again, even if you accepted it as you said, okay, go ahead with that, the amount of energy you'd have to have created in your ether, the amount of stirring in the ether would have to be an insane amount to create the strength of the average magnet. I mean, magnets are incredibly powerful. I mean, I want to do an experiment with this someday. It's a little steel ball. You can put magnets in it. And the funny thing is when you put the magnets inside the little steel ball, the steel ball is not magnetic, barely magnetic. And yet there's very powerful magnets inside. So it's a nice example of the fact that magnetism is consumed by. I mean, just really strong. Now, for things to move across space, to violate gravity in such a dramatic way, it's just really implausible to think that that's happening because of the GNU effect. Because the amount of energy that would have to be swirling the ether, it'd have to be swirling at an insane rate. So anyway, yeah. So these are the kind of exaggerations that don't do dissonance any good. Don't give them a good name. That they're just doing the same thing. It seems like, it looks a little tiny bit like, so there's the same wrong conclusions they drew with the whole interference pattern. Because light created an on-off pattern, and that water waves create an on-off pattern when they're truly interfering. So it's just, so it seems like, so it is like. And it isn't. The right answer is a little more complicated. You have to look a little harder than just do this it seems like thing. It's barely similar. Barely similar is not good enough.
And so this is where the idea of fluid dynamics, mimicking magnetic fields, came to me.
Right. So again, it doesn't mimic it at all. It's such a it's so tiny a similar. I don't even know how to describe how tiny the similarity is. It's like saying, we're, the same as. I mean, some bugs have forward-looking eyes, and they sort of look, it means we're the same thing. It's way too distant a similarity.
To my mind. And so that's what got me thinking about fluid dynamics in general, being able to mimic all the phenomena in nature.
Well, it doesn't do that at all. It's certainly not going to do a proton and an electron. You can spin them all day long, and you're really not going to get anywhere close. I don't know why people are so attached to this wavical nonsense. You can't do it with just saying there's waves. You have to, to create the phenomenon of charge, you're going to have to recognize that there's fundamentally different things that the two things are reacting to. You can't have the inverse relationship without having something inverse in the field. A solid ether of one solid stuff won't work. You're never going to get there from there.
So here we're going to review this paper. What I'm going to do is I'm going to review this paper. This might be a fairly long video, but I think this is very...
Yeah, it's only 10 minutes, 15 minutes. So anyway, we won't play the whole review. The review is just sort of saying that, Maxwell wasn't completely right, blah, 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 blah. And of course he wasn't. He didn't have complete knowledge. The equations are, generally speaking, going to get you right answers. I'd argue they're completely flawed in the sense of identifying two different fields, electric and magnetic. There's not two different fields. There's two different kinds of force, proton force and electron force, and different expressions are made of different things. Atoms create sound, the movement of whole atoms, and other phenomena are created by the movement of electrons because they're on the outside of atoms. Atoms really can't communicate to each other proton to proton. They sort of communicate to each other electron to electron. And the only time it's proton to electron is when they do have an opening, okay, a place where there's no electron. and then they connect to each other and become a compound or a molecule. They create a molecular bond, and that makes, obviously, when they're molecularly bonded, where they bonded by. The same thing the regular atom is, that is the tension between the electrons and the proton. They're attracted to the proton, but the electrons don't allow the other electrons to move closer to the proton without pushing against the other electrons, and that's the spring. That's the mechanism that creates the time delay, that creates the tension, that enables you to have an oscillating system, in the sense that you push energy one way, you push it forward, it rocks back. You wait for it to rock back, you push it forward again. That's why electricity, to create transmittable electricity, you have to have an oscillating current, because to keep pushing, you have to let it spring back first. The atoms have to spring back before you push them again. You know, the electrons attached to the atoms. And if you just keep pushing, then you won't be able to create a transmittable induction in another substance, because you won't be creating a field that's expanding and contracting. It needs to contract before it can expand. It needs to contract before it can expand. And if you just keep pushing out, there's no opportunity for the system to relax so you can push it again. I mean, once you knock them over, there's nothing can happen. They can't move anywhere, but you keep pushing them into the same pressure. Is the simple answer. All right, so the second part of this video is a little more interesting, because at least it has some graphics in it, something happening. So maybe we'll play some of this. So it's a list of the equations, Gauss's law, which is the kind of obvious one.
1 over permittivity, that's this here, that's the permittivity of free space, times the net electric charge enclosed within that surface.
So this is just a simple rule that, the energy is coming from the charge, in terms of it's going to reflect to the universe what's coming into it. It's going to be at a kind of equilibrium, generally speaking. And so whatever comes in is basically going out. And the idea would be is that the what's going in and out, what's reflecting purely, for the two things, electrons and protons, are two fundamentally different forces that they're reflecting. All right, and so the inverse part is that if a white bit of force goes into a blue bit of force, it ends up leaving perpendicularly. And if a blue bit of force goes into a white proton or electron, it goes out perpendicularly. And that's what kind of makes the game interesting, is because now the two objects can't reflect force back and forth, because every bit of white force that heads for the blue goes out perpendicularly, and every bit of blue force trapped would go out perpendicularly. So you end up with a low pressure between here, these two objects, and they attract each other. But the real point is the force is radial from the charge in all directions. Even if it's in a neutral environment, there is no other charge anywhere near it. It's just doing this. It's just reflecting the universe as it comes into it, and it doesn't mean anything. But as soon as you bring another object in here, another electron, then it's going to be reflecting also, and whatever gets caught between them will reflect quickly, back and forth, back and forth. The closer they get, the more interactions it's going to have. It'll double them. And that's what creates the force between charges, the R rule for charges, instead of the R squared, is that this is the repulsive force. So you're attracting this way, you're repelling this way. That's the nature of charges. And the idea is that I can put a surface this big, and it has a certain area to it. But it's going to collect exactly the same amount of force as a surface this big, in terms of if it was to be able to collect after things go in, it's collecting the reflections, so to speak. You can understand that it's the same amount of force, because its force is essentially coming from its reflections to the outside world, and those reflections, let's see how to put this in some sort of terms that can be understood. Well, it's just going to be distributed on another surface. The surface is bigger. That means the density of the charge on this surface is going to be less than the density of the charge on this surface. Blah, 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 blah. I think I said that right. Yeah, no, the voltage will be the same. So the pressure will be the same, no matter how big I make the surface, because I'm starting with the same amount of energy. Close enough. So we'll move on to the magnet part. Let's see what this part is.
Electrostatic law, and I'm going to call this the magnetostatic law.
Okay, so this is the part. So this is the part where they claim there's no magnetic monopoles. It clearly doesn't really say that. Okay, it's just saying that if I make a dipole, there's no change because there's just as much attractive force as there is repelling force. So you're back to the purple argument that a dipole is going to push something away as much as it's attracting, so to speak. So the idea would be is that it's shooting energy in all these directions, and at this end it's going to be very pink, okay, and at this other end it's going to be very blue. All right, but the nature of it is that it's going, these two mix here, and besides that, whatever attraction you get from this one, you're going to get the same amount of repulsion from this one. So whatever you are, if you're blue, all right, then you're going to be repelled over here and then attracted over there, and those two are always going to be equal. So the amount of repulsion or attraction in any one movement is going to be, because it's a dipole, it's going to be doing both effects. So clearly, yes, there won't be any difference. It has to come out to zero in the sense that this is a zero. If you add up how much blue is hitting this side and how much red is hitting this side, they're the same amount, and you end up with zero as a net effect. And that's because it's a dipole. Okay, so how does that say anything about monopoles? It doesn't say anything about a monopole. It doesn't say anything about the fact that I can actually take electrons and put them over here, and I can take a proton and move it over here, and they're not a dipole anymore, but they're still the elements of a dipole. So atoms are magnets. They make things magnetic, and the magnetic monopoles are the same as the electric monopoles, so to speak. There's no such thing really, because there's no such thing as a pure electric dipole. You can force an electron next to a proton and create a fake. Well, it's not even fake. It's a magnetic dipole, but it's also going to be a charged dipole. And the only problem is we can't see one that small, so we can't do much with them. But as a practical fact, if I took two charged objects and they wouldn't discharge, that is, they're in a perfect vacuum, and I put them insanely close to each other, they'll behave as an instrument just like a magnet, in the sense that I could put another dipole near them and I'll have them behave just like magnets do. Red ends will turn to blue ends, and they'll turn and attract. So they'll behave. Unlike their statement, the new effect, two charged objects will behave just like in a vacuum, where you don't discharge them of their voltage. They'll behave just like a magnet, because it's all one force, with two varieties, of course. Just like there's only two kinds of matters, electron and proton. There's only two kinds of force, electron force, proton force. And that's all there is. And the one that we really see a lot of is the electron force, because electrons are on the outside of atoms, and they can do a lot of interacting. All right, so this is just a kind of a meaningless statement when obviously, a dipole isn't a monopole. And you haven't proven there's no monopoles by saying what happens. What's the magnetic field around a dipole? Yes, of course it's neutral. There's as much positive as there is negative. It's electrically neutral.
That are not in motion. Okay, so This law states that the net.
So again, motion is the key word here, so we'll come back to that and just sum up with that maybe. I don't know if we need to go into a great deal of this other stuff. So again, back to the original story. All this stuff is moving because of the environment it exists in. The environment moves everything. Nothing moves on its own. Nothing. It has to trap some element of the universe that's doing something for it to do something. There's no I'm just going to do it thing. So everything is Newtonian in the sense that there has to be a movement somewhere. So when they say a moving charge does something, all they're saying is that, yes, of course, if I put the charge in another location, something's radiating energy. It's reflecting the universe. What's reflecting it from this location? Well, if I change its location, obviously it's reflecting it from a different place and a different distance from everything else now in the universe. It's closer to an object over here, it's further from an object over here, it's closer or further, and it's constantly shooting force back and forth between each other, and they all know about the fact that it moved. They're all communicating with the force. The force, the force, the force. And photons are just force in a specific configuration where there's a specific frequency that allows the tension between electrons and protons to be broken or disturbed in a specific way. It causes the electron to move in a specific direction. The electron wants to move back, and when it does that, it's going to change the force reflecting off of the new locations. But it's just force, and it's just force at a frequency we can see. We see this, okay? We don't see this because it's not a long enough ray. We don't see this, because the phase, the frequency is wrong. It's this one's too close, this one's too far away. And we don't see this if there was one taken out of here because now we moved its phase and now it's over here lined up next to this one. Well, we're not going to see that either. And we can only see it when it's in the right amount of it and it has the right frequency. Then we can make a detector that can see it. But the amount of force is insane. That's hitting you all the time. You're being pushed together. You're not oscillating from the inside out and then throwing stuff at other stuff and then it bounces back and keeps you together, right? I mean, how much sense does it make, right? I mean, their theory is essentially saying that the matter has the energy. And if you give the matter the energy, so if you make your little, your stupid little jellyfish, oscillating. I'm an oscillating jellyfish, and I'm oscillating water out, right? You know that if you have to depend on the water, okay, bouncing off another surface and coming back to you, that the amount of energy going out in your cell is going to be, 1,000,000 times, 10 times 38 power amount of extra. You're going to have more energy pushing you to pieces than you are going to have energy pushing you together. There's going to be an insane imbalance between those two. The energy has to come from the outside in. It's just the only logical conclusion, and I just don't know why you people are so belligerent in accepting what is obvious. I mean, it's just push is so simple. Pull is impossible. So anyway, I've done my job, I think. Yeah, I'll call it my job. Good enough. So till the next time and such. And so forth.